Welcome back to the deep dive. Usually we like to, take a step back, maybe look at a historical event or a broad scientific concept.
Right, get that 30,000-foot view.
Exactly. But today we are planting our feet firmly in the absolute now.
And the now is moving very, very fast.
It's moving so fast, it is actually kind of disorienting. It is, February 2026?
It certainly is. And if you have been feeling like the ground is just constantly shifting under your feet with technology, you are not crazy.
Not at all.
The last few months have felt like a decade in this field.
Oh, absolutely. I feel like every single time I refresh my feed, there's a new model, a new breakthrough, or a new warning that we're all about to be made obsolete.
It's a lot of noise. It's hard to separate the signal from the hype.
So to make sense of all this chaos, we're doing a proper State of the Union. We are diving into a massive, and I mean massive, nearly 5-hour technical breakdown of the AI landscape as it stands right this second.
And we really couldn't ask for better guides to get us through this. The source material we're deconstructing today features two absolute heavyweights in the field.
Yeah, they're the real deal.
First, we have Nathan Lambert. He's the post-training lead at the Allen Institute for AI, or AI2.
Okay.
And he literally wrote the book on RLHF. It's called the RLHF book.
Which, for those of us who don't, speak the acronyms fluently, that's essentially the Bible on how we teach these digital brains to be human-friendly, right?
Precisely. RLHF stands for Reinforcement Learning from Human Feedback. It's the secret sauce, the finishing school that turned GPT-3, which was just a raw text predictor.
A very smart parrot, basically.
A very smart parrot, exactly. It turned that into ChatGPT, which is, a helpful assistant. So Lambert knows exactly how the sausage is made.
And on the other side of the table in this discussion, we have Sebastian Raschka.
A legendary educator in this space. I mean, so many people have learned machine learning from his work.
And he just released a book with a title that I think just perfectly captures the moment we're in. It's called Build a Reasoning Model from Scratch.
And that title is key. That one word, reasoning.
Right.
2 years ago, we were building language models, or chatbots. Today, we are building reasoning models. That is the fundamental shift we are going to explore.
So here's the mission for this deep dive. We are going to try and bypass the marketing hype.
All of it?
I don't care about the press releases. I don't care about the slick demos. I want to know what is actually happening inside the labs.
We're looking at the machinery.
Exactly. The machinery of 2026. Reasoning models, these new coding agents, the massive infrastructure, and the geopolitical chess game that is driving all of this forward.
You have to cover the whole stack. You can't just talk about the software. It's from the silicon all the way up to the sociology of the labs.
And we are going to tackle the big, maybe even the scary questions that the source material raises.
Yeah, they don't pull any punches.
Not at all. Like, is the scaling law era over? That whole idea that if we just make the computer bigger and feed it more data, it just gets smarter forever.
The brute force method.
Right. Is it hitting a wall? And the one everyone's worried about are programmers actually being replaced this year in 2026. And the big one, who is winning the race between the U.S. and China?
The answers to those questions are, well, they're not what you might expect from the headlines. The data suggests we are at a really significant pivot point.
It feels heavy, doesn't it? I mean, listening to these guys talk for 5 hours, it doesn't feel like they're discussing a product launch.
Not at all.
It feels like they're discussing the future of civilization.
That is because they are. And we need to look at the nuance here. Specifically, that shift we mentioned from just training models to reasoning with them.
Okay.
It sounds like a small semantic difference, but it changes everything. It changes the economics, the hardware requirements, and the ultimate capabilities of AI.
Okay, let's unpack this. We have to start with the horse race. I mean, even if we want to be high-minded philosophers about it, everyone wants to know who is winning.
It's the first question everyone asks.
So in February 2026, what does the leaderboard look like?
It is crowded, and it's complicated. The source material explicitly compares the big four that are really defining the landscape right now. You've got ChatGPT.
The incumbent.
Right. OpenAI's model. Then you have Claude from Anthropic.
The thoughtful one.
The thoughtful, safety-conscious one. Then Google's Gemini.
The massive, integrated everywhere one.
And the newcomer, Grok from xAI.
The edgy one.
Yeah, yes, the edgy one. And a couple of years ago, comparing them was just about, which one tells a better joke or which one doesn't hallucinate a fake court case.
Right. The bar was pretty low looking back.
The metrics have shifted completely. It is no longer about fluency or creativity in that simple sense. They are all incredibly fluent.
That's table stakes now.
It's totally table stakes.
Yeah.
The new comparison is about utility, reasoning, and integration.
Okay, what does that mean, utility?
It means, can I actually get my work done with this thing? How many steps can it do on its own? And Lambert and Raschka, they break this down in a really interesting way. They talk about vibes versus benchmarks.
Vibes is a scientific metric now. I love it.
Surprisingly, yes, it's a recognized term of art. It refers to how the model feels to use in a real workflow.
Okay, give me an example.
For example, Claude might have a vibe of being more thoughtful and concise. If you're a writer trying to brainstorm, it might just feel better, more collaborative.
It gives you less fluff.
Exactly. Whereas Gemini might feel more integrated. It's tied into your Google Drive, your email. Its utility comes from its place in a huge ecosystem. It feels powerful in a different way.
And the benchmarks, the hard numbers.
The benchmarks are getting much tougher. It's not about standardized tests anymore. It's about multi-step reasoning. Can it hold a complex logical structure in its head for 30 turns of conversation?
So it's less, write me a poem about a cat, and more, help me debug this 10,000-line code base and explain the error in plain English.
Precisely. Can it plan 3 steps ahead? Can it recognize when its first idea was wrong and backtrack? That is the real differentiator now.
Which brings us to this divide that really defines the whole industry, doesn't it? Open source versus closed source.
This is maybe the most important battle being waged.
It's the David and Goliath story. You have the closed giants, OpenAI, Google, Anthropic keeping their secret sauce, the model weights locked up in a digital vault.
Right. You can use their product through an API, but you can't see how it works. You can't modify it.
And then you have the open source community championed by places like AI2 or Lambert Works and Meta to an extent.
And companies like Mistral and Llama.
Trying to democratize this.
Yeah.
To give the tools to everyone. So where do we stand on that in 2026? Is David catching up? Is the gap closing?
It is a fascinating dynamic. If you had asked me this in, say, 2023, I would have said the closed models would always be 2, maybe 3 years ahead. The resources were just too vast.
That was the conventional wisdom.
It was.
Yeah.
But in 2026, the gap is narrowing significantly. And in some areas, it's actually closed.
How is that possible? They don't have the same money.
They don't, and that's the key. It's because of efficiency. The open source community can't afford a $100 billion training cluster. They can't just brute force it.
So they have to be smarter.
They have to be smarter. They have to optimize. They have to innovate on the architecture and the training data. Lambert points out that for specific, narrow tasks,
Like what?
like, say, coding in Python, or summarizing medical texts, or translating between 2 specific languages. For those tasks, there are now open source models that are on par with, or even better than, the closed giants.
So the moat that big tech thought they had, that only they could afford to build the best models, that's drying up.
The software moat is drying up. The idea that there's some magic algorithm that only they have,
Yeah.
that's looking less and less true, but, and this is a huge but,
What?
the hardware moat is getting wider and deeper every day. And that is where we have to zoom out. We have to go from looking at the companies to looking at the countries.
Yeah, this part of the source material,
Yeah.
it actually gave me chills. They used a phrase that just stopped me cold. They called it a Manhattan Project for AI.
It is not a light comparison, and they don't use it lightly.
No. I mean, the Manhattan Project was the development of the atomic bomb during World War II. It implies state-level secrecy, an almost unlimited budget, and absolutely existential stakes. Are we really there?
According to the experts in this breakdown, we are absolutely there. In 2026, AI is no longer viewed just as a commercial product. It is viewed as core national security infrastructure.
Like the power grid or the highway system?
Oh, exactly. Or like nuclear weapons technology in the 1940s. The source discusses the race between the U.S. and China. And it is crystal clear that this is being fought on the level of industrial capacity.
So it's not just about who has the cleverest algorithm anymore.
No.
It's about who has the most power plants.
Correct. It's about energy. It's about the chip fabrication plants. It's about the data centers. The Manhattan Project concept implies that the U.S. government is likely coordinating with these labs, OpenAI, Google, Anthropic, in ways that we don't fully see.
Behind the scenes.
Very much so. We are talking about securing the supply chain of intelligence itself. Who can build the biggest brains the fastest? That is a national security question now.
So who is winning, based on what they're saying?
The consensus in the source is that the U.S. still holds the lead.
Why?
primarily for two reasons. First, the chip embargoes. The U.S. has been very effective at restricting China's access to the absolute cutting-edge GPUs from NVIDIA.
The hardware moat.
The hardware moat. And second is just the sheer maturity of the ecosystem in Silicon Valley. The talent, the research labs, the venture capital. It's a flywheel that's been spinning for decades, but
Right.
China is pivoting.
Pivoting how?
Well, if you can't get the biggest, fastest chips, the NVIDIA Blackwells and the new Rubins, you have to get creative.
You can't win with brute force, so you have to be clever.
Exactly. China is focusing heavily on efficiency. They're pouring research into new architectures, new algorithms, into reasoning models that can do more with less compute. They're being forced to innovate on the software because they are constrained on the hardware.
That is the classic necessity is the mother of invention scenario.
It is. And that, in the long run, makes them an extremely dangerous competitor.
How so?
Because if they figure out how to run AGI-level intelligence on consumer-grade hardware, while the U.S. is still building dedicated nuclear reactors to power its data centers,
That's a strategic upset of epic proportions.
it changes the entire game. And it puts those stories we hear about the work culture into a new perspective.
The 72-hour work weeks.
Yeah. It's not just startup hustle culture anymore. It's not about getting rich. There's a palpable feeling of, if we slow down, we lose the century.
It's an arms race.
It is an arms race, plain and simple.
Yeah, okay, let's look under the hood. Because to understand why this race is so expensive, why it requires so much energy, we have to understand what these things actually are. How has the core technology changed since, say, 2019?
It all goes back to the transformer.
Which is the architecture, not the robot car from the 80s.
Right. Chuckles the transformer architecture. It was introduced by Google researchers back in 2017 in a paper called Attention is All You Need.
Pretty bold title.
It turned out to be true. It really took off around 2019 with models like GPT-2, and here we are in 2026. And shockingly, we are still using it.
That is surprising to me. I mean, in the tech world, 7 years is a lifetime. You'd expect me to move on to something completely different by now.
It is a testament to how fundamentally robust and scalable the architecture is. The core mechanism of attention, the ability for the model to look at a whole sentence or a whole document and understand how every single word relates to every other word, that is still the bedrock.
Okay, so the foundation is the same.
The foundation is the same, but the way we use it, the way we build on top of it, has changed dramatically. And this brings us to the biggest debate in the entire source material,
Which is?
the scaling laws.
Scale's all you need. That was the mantra for years, right?
It was the gospel. Just add more data, buy more GPUs, make the model bigger, and intelligence will just magically emerge.
Use the free lunch theory of AI. Just get bigger.
Exactly. And for a while, it worked incredibly well. But in 2026, the source poses the big question. Are the scaling laws dead?
No, they.
They aren't dead, but they are hitting a very, very hard wall of diminishing returns.
Okay, explain that.
Think of it like mining for gold. In the beginning, the gold nuggets were just lying on the surface. That was the public internet, Wikipedia, Reddit, books, articles. We scooped all of that up.
The easy data.
The easy, high-quality data. Now, to get more gold, you have to dig a mile deep through solid rock for just a few flakes. The cost has gone up exponentially for each new IQ point.
So the problem is we've run out of data.
We have run out of high-quality human data. We have, for all practical purposes, read every book, every website, every scientific paper, every GitHub repository.
We've ingested all of human knowledge.
Pretty much. So to get smarter, the models need more data, but that human-generated data just doesn't exist anymore. We'd have to wait for humanity to write more books for the next 100 years.
So this is why labs are talking about synthetic data,
Yeah.
right? Having AIs generate data to train other AIs.
Precisely. And that's a whole can of worms. It's a huge area of research, but it's risky. You could end up with an AI learning from a slightly dumber version of itself, creating a feedback loop of weirdness.
AI inbreeding.
That's a good way to put it. So if the just make it bigger strategy is failing, or at least becoming prohibitively expensive, where is the improvement coming from? Because the models are getting better month by month.
Right, that's the paradox. If scale isn't the answer, what is?
The improvement is shifting. It's shifting from the training phase to the post-training phase.
The source called this the training triptych. I like that. Pre, mid, and post. Break that down for us.
Okay, so phase one is pre-training. That is the brute force phase. That's the reading the entire internet part we just talked about.
The expensive part.
Incredibly expensive. It takes months, sometimes over a year, and uses tens of thousands of GPUs running 24/7. The result is what's called a base model.
And base model is?
It's a model that knows a lot of facts, but it's kind of a chaotic, unusable mess. It can complete sentences, but it has no sense of what's helpful or harmful or true.
So it's a genius with absolutely no social skills.
Exactly, a brilliant, unfiltered oracle. Then you have phase 2, which is mid-training or supervised fine-tuning. This is a refinement stage where you start to show it examples of good conversations.
Giving it some basic manners.
Right. But phase 3, post-training, is where all the exciting new research is happening. This is Nathan Lambert's specialty. This is where we take that raw statistical engine and we turn it into a useful, reliable tool.
Okay, how do you do that? What's involved?
You use techniques like RLHF, that reinforcement learning from human feedback.
Yeah.
You basically have humans, and now other AIs, grade the model's homework on a massive scale.
So you have it generate 2 different answers to a question.
And a human says, this one is better. And you do that millions of times. You give it feedback, good answer, bad answer. This one was too aggressive. This one was too vague. You are actively shaping its behavior, its personality.
So pre-training gives it the raw IQ, and post-training gives it the personality and the safety guardrails.
And crucially, the reasoning ability. In 2026, the big breakthrough is that we're not just using post-training to make it nice. We're using it to teach the model how to think through a problem step by step.
Which is a perfect segue into the next big topic from the source. Reasoning models. This is Sebastian Raschka's whole thing, his book, Build a Reasoning Model.
It is.
I feel like we use the word reasoning very loosely. What does it actually mean for a piece of software to reason?
It's a great question, and the best framework for it, which they discuss, comes from the Nobel Prize-winning psychologist Daniel Kahneman.
Thinking fast and slow.
Exactly. System 1 versus System 2 thinking.
System 1 is fast, intuitive, automatic.
Right. A standard LLM, like the early ChatGPT from 2023, is a pure System 1 machine. It's all fast, instinctive pattern matching. You ask it a question, and it predicts the most likely next word, then the next, all in a fraction of a second.
It doesn't think, it just reacts.
Perfectly put. It's like when someone asks you what's 2 plus 2, you don't do the math in your head. The answer 4 just appears. That's System 1.
Right. But if you ask me, what is 17 times 43 divided by 9?
You can't just know it. You have to stop. You have to engage System 2. You have to think slowly. You have to break the problem down. Okay, first, what's 17 times 40? Then I'll add 17 times 3.
I have to work through the steps. I have to use a process.
A reasoning model is an AI that has been trained to do that. Instead of just spitting out a final answer, it generates a chain of thought.
Okay.
It actually talks to itself first, internally. It will say, okay, the user is asking me to debug their code. Step 1, I need to identify the variables. Step 2, I need to trace the logic of the function. Step 3, I see a potential off by 1 error here. Step 4, I will formulate a corrected version of the code and an explanation.
So it's showing its work, just like in math class.
And by showing its work, it dramatically increases its accuracy. It catches its own hallucinations. It creates an internal feedback loop of logic before it ever gives you the final answer. That is the reasoning breakthrough of 2026.
That sounds incredibly useful, especially for complex things like math or coding.
It is a complete game changer, and it leads to this new concept that's dominating the industry: inference time compute.
That's a jargon term. What does it mean?
It means we are spending a lot more computing power after the user asks the question.
Yeah.
The old way was a fast, cheap answer. The model spits it out instantly. The new way, with reasoning models, we're willing to let the model think for 10 seconds, 30 seconds, maybe even a couple of minutes on a really hard problem.
So the compute happens during the inference, which is the answering phase, not just during the big upfront training phase.
Exactly. We're trading a little bit of time for a massive leap in accuracy and reliability.
And for high-value tasks, that's a trade you make every time.
Absolutely. If you're a doctor trying to get a differential diagnosis, or a scientist analyzing data, or a programmer writing a complex software architecture, waiting 30 seconds for a much, much better answer is absolutely worth it.
Let's talk about those high-value tasks. Let's talk about the one that has everyone sweaty-palmed: coding. The source specifically asks the question, will AI replace programmers?
It is the billion-dollar question, isn't it? And the source material is very specific and nuanced about this. The role of the programmer is not disappearing, but it is undergoing a violent evolution.
Violent evolution. That sounds comforting.
Well, think about it. For the last 40 years, what was programming? A huge part of it was about syntax. It was about knowing where the semicolon goes. It was about memorizing obscure library functions.
The boilerplate stuff.
Right. In 2026, the AI knows the syntax better than any human ever will. It doesn't make typos. It has every library ever written memorized.
So if I'm a junior developer whose main skill is that I know how to write a basic Python script, am I in trouble?
If your only value is, I can type code, then yes, you are in deep trouble. Your job is being automated. But if your value is, I can solve complex problems using code, you are about to become more powerful than ever.
So what's the shift?
The source describes a shift from writing code to architecting agents.
Meaning, what's the difference?
Meaning, you aren't laying the individual bricks anymore. You are the site foreman or even the architect. You stand back and you tell the AI agent, okay, build me a user login system. It needs to use OAuth 2.0 for authentication, connect to a PostgreSQL database with the schema, and it has to be resilient to SQL injection attacks.
And the AI just writes the 500 lines of code to do that.
It writes the 500 lines of code. Your job is to look at the blueprint it generates, look at the code and say, wait a minute, that database connection isn't properly pooled, that won't scale, or you missed an edge case in the error handling here.
So you need more deep knowledge, not less. You need to understand the system at a much higher level so you can effectively direct and correct the machine.
Exactly. You become an editor, a verifier, a prompter. And you become a manager of a team of AI agents.
Let's define agents, because that's another buzzword that is morphed. A chatbot talks to you. What does an agent do?
An agent acts on your behalf. A chatbot is a brain in a jar. It can give you advice, but it can't touch the world. An agent has hands, digitally speaking. It has the ability to use tools.
Give me a concrete example.
Okay. A chatbot can tell you the steps for how to book a flight. An agent can open a web browser, navigate to the airline's website, look for the cheapest flight on the dates you specified, select the seats, enter your saved credit card information, complete the purchase, and then send the confirmation code to your calendar.
That is a massive, massive difference.
It is the difference between a consultant and an employee. And in 2026, we are seeing the rise of coding agents that can be given a bug report from a user. And the agent can check out the correct search from the code repository, find the relevant files, write the code to fix the bug, write new unit tests to make sure the fix works, run all the tests, and if they pass, submit a pull request for a human to review.
Without a human touching the keyboard for any of that.
Without a human touching the keyboard. But, and this is a really big but, the human has to be there to define the goal and, most importantly, to verify the final result. Because if an agent goes off the rails, it can do a lot of damage very, very quickly.
So we're basically building a workforce of incredibly fast, incredibly cheap digital interns who are brilliant but have no common sense.
That is the perfect analogy, and they need constant supervision. But they have one superpower that no human intern has.
Which is?
An almost infinitely long memory. They have long context.
Long context. That refers to how much you can remember at once, right?
Basically, yes. The context window is how much information the AI can hold in its working memory at any given time. In the old days of 2023, it was maybe a few pages of text.
And now?
In 2026, the top models can ingest millions of tokens of context. That's entire code bases, entire libraries of books, hours of video transcripts, all at once.
And why does that matter for an agent?
Because an agent can't work for you effectively if it doesn't know you and your specific situation. With long context, you can feed it your company's entire 10-year history, all of your internal documentation, all your Slack logs.
So it understands the specific context of my business.
Exactly. It's not just a generic coder anymore. It's your coder who knows your coding style, your business goals, and your past mistakes.
That is incredibly powerful. But it also sounds incredibly resource-intensive.
It is, which brings us right back to the brutal reality of the industry, the money, the pressure, and the culture.
Yeah, the source material paints a pretty intense picture of what it's like in Silicon Valley right now. They specifically mention 72-plus-hour weeks as being the norm.
Yeah. That Manhattan Project mentality we talked about isn't just about government contracts. It's about the lived reality, the work culture inside these labs.
If you genuinely believe you are building the last invention humanity will ever need to make, artificial general intelligence, you don't clock out at 5 p.m. on a Friday.
You don't. The stakes feel too high.
But is that sustainable? I mean, human beings break. You can't run at that pace forever.
They do break, and the source talks about massive burnout. But the labs OpenAI, Google DeepMind, Anthropic, xAI, Meta, they're all caught in a classic prisoner's dilemma.
How so?
If they slow down to create a healthier work-life balance, the other guy wins. If the U.S. ecosystem slows down, China wins. So nobody can afford to be the first to slow down.
It's a death march to the future, then.
And it's a death march fueled by an absolutely incredible amount of capital, which leads to the question the source asks, is this a bubble?
It has to be, right?
Yeah.
The valuations are in the trillions of dollars. It feels a lot like the dot-com boom in 1999.
There are definite similarities. The hype is off the charts. But the source makes a very key distinction.
Okay.
In the dot-com bubble, you had companies like Pets.com going public with no real product and absolutely no revenue. It was pure speculation.
I mean, this is all based on future promises.
In 2026, these AI companies are printing money.
Real revenue, not just investor cash.
Massive, massive real revenue. Making money is a specific section in this analysis. Large enterprises are paying millions a year for these agents. Individual coders are paying for assistance. Governments are signing huge contracts. The utility is real, and people are paying for it.
So the stock prices might be hyped, but the underlying business model is actually solid.
It's incredibly solid, and when you have a solid, profitable new industry, that usually leads to one thing.
Consolidation. The big fish eat the little fish.
And we are seeing that in a huge way. The source specifically notes the big acquisitions in 2026. The ecosystem is solidifying around a few massive poles of power.
Who are the big players?
You basically have the Microsoft OpenAI pole, you have the Google pole, you have the Amazon Anthropic pole, and then you have Meta trying to be the Switzerland of the open source world.
It's like the new Standard Oil.
Oh,
Few trusts controlling the key resource.
It really is. And the oil in this analogy is compute.
Let's talk about the engine room. Because none of this software runs on magic. It runs on physical metal in a building somewhere.
It runs on NVIDIA GPUs.
Still, after all this time, they still have a monopoly.
Still, competitors are trying, but NVIDIA is the kingmaker. Their lead is immense. And the source talks about the scale of these AI compute clusters. We really need to wrap our heads around this. We are not talking about a server room in the basement of an office building anymore.
What are we talking about then?
We are talking about single data centers that cost $100 billion to build.
$100 billion for one building.
Yes. We are talking about facilities that are so power hungry they require their own dedicated power plants to run. The source mentions the energy constraint as the single biggest bottleneck to progress in 2026.
So it's not the algorithms, it's not even the chips. We have the chips, we have the code, but we just don't have enough electricity.
Exactly. AI is incredibly hungry. A reasoning model that thinks for 30 seconds to give you a good answer burns a lot of watts. If we want to scale this up to true AGI across the whole planet, we need a complete overhaul of our global energy grid.
We're talking about a new era of building nuclear plants.
We're talking about nuclear, fusion research, massive new solar and wind arrays. The future of AI is a problem of physics and civil engineering.
It's ironic, isn't it? This ethereal digital future depends on the most industrial, physical, dirty thing possible, generating electricity.
It anchors the cloud firmly to the ground.
So let's look out at the horizon. We're building these massive billion-dollar clusters. We're trying to solve the energy crisis. What is the end goal? The source talks about it, AGI, artificial general intelligence.
The Holy Grail. The final invention. A machine that can perform any intellectual task that a human can.
The timelines for this have been all over the place for years.
Yeah.
What's the consensus looking like in February 2026?
Well, you know, predictions are always a fool's game in this field. Yeah. But the source raises a very provocative counterpoint that I found absolutely fascinating.
What?
They ask the question, is the dream of AGI dying?
Wait, dying? How can it be dying? We just spent the last 40 minutes talking about how fast everything is moving.
It all depends on how you define AGI. For decades, the sci-fi dream of AGI, the goal, was a conscious robot. It was Data from Star Trek, something that is self-aware, that has feelings, that is alive.
Right, a synthetic being, something with a soul, for lack of a better word.
And the experts in the field are starting to come to a consensus that LLMs, large language models, no matter how big we make them, might never get there.
Why not?
Because at their core, they are statistical engines. They are incredibly sophisticated mimics of reasoning and emotion, but they don't actually experience the world. They have no body, no senses, no internal motivations. They might never be truly sentient.
So we might get a machine that is 1,000 times smarter than Einstein, but it's essentially a dead object.
Yeah.
A very, very smart rock.
Exactly. We might achieve superintelligence without ever achieving consciousness.
Does that distinction actually matter in the real world?
Practically, maybe not. If it can cure cancer, design a workable fusion reactor, and manage the global economy, who cares if it has feelings or not?
But philosophically?
Philosophically, it matters a great deal. But what we're seeing is the industry pivoting. It's pivoting from let's build a conscious God in a box to let's build a supremely effective, omniscient, but unconscious oracle and employee. The definition of the finish line is changing.
That is a really profound shift. We're lowering the bar on magic and raising the bar on practical utility.
That's a great way to put it.
Now, before we wrap up, I want to pivot to you, the listener, because we have thrown a lot of heavy concepts at you. Scaling laws, geopolitical warfare, reasoning architectures, tool use.
It's a fire hose of information.
It is. And it's easy to feel small. It is so easy to feel like the train has already left the station at 1,000,000 miles an hour and you were just standing on the platform.
And that is absolutely the worst possible takeaway from all of this.
Why?
Because, as our guides in the source material, Lambert and Raschka both emphasize, and you have to remember, they are educators at heart, it is not too late to get involved. In fact, it's the perfect time to jump in.
But don't I need a PhD in advanced mathematics from MIT to even begin to understand this stuff?
To build the next foundational model from scratch, to be at the absolute bleeding edge of the research, yes, maybe, but to use it, to apply it to solve real-world problems, absolutely not.
So the barrier to entry is lower than it seems.
Much lower. The field is still messy. It's still being defined day by day. We have this incredible new power, but we still don't really know what to do with it. We need people who understand the why, not just the how.
We need people to figure out what problems to point these agents at.
Exactly. We need domain experts. We need doctors who understand AI. We need lawyers who understand AI. We need city planners, artists, and teachers who understand how to use these tools. The actual coding part is getting easier and easier. The knowing what to build part is getting harder and more valuable.
So the value of human judgment, of taste and wisdom is actually going up, not down.
I absolutely believe so. The AI can generate 1,000 different business plans or 1,000 different architectural designs in a minute. A human needs to be there to pick the one good one.
That is genuinely reassuring.
And remember, the best way to learn about AI is to use AI. You have the world's greatest, most patient tutor sitting right there in your web browser. Ask it to explain these concepts. Ask it to help you write your first line of code. The barrier to entry for learning has never, ever been lower.
So the message is, don't be intimidated. Be curious.
Always be curious.
Okay, as we close out, let's touch on the existential reflection from the source. Because you can't talk about this subject for 5 hours without getting a little deep.
It's impossible not to.
The source talks about the future of human civilization.
Big words.
But they kind of fit the scale of the moment, don't they? We are living through the biggest technological shift since
What?
the printing press, agriculture.
It might be on the level of the discovery of fire. I mean, we are outsourcing intelligence. We are creating a second intelligent species on Earth, in a way.
And the source leaves us with this final, really provocative thought to chew on. We talked about the speed, the Manhattan Project urgency, the 72-hour work weeks.
So the race.
The race. And the question is, are we building these systems too fast to understand them?
That is the core tension of our time. We are absolutely building the plane while we are flying it. And we are flying it at Mach 10 through a hurricane.
Is it reckless? Are we going to lose control?
Maybe. It's a real risk. But the counter-argument, which the source touches on, is a heavy one. Is this speed actually necessary?
Necessary for what? To beat the competition.
Not just that. Necessary to solve the other existential problems we've created for ourselves. Climate change, pandemics, resource scarcity.
Yeah.
We are running out of time on a lot of other clocks.
So the idea is that AGI might be the only tool powerful enough to get us out of the messes we're already in?
It might be the only way to beat those other clocks. So we are racing against our own self-inflicted extinction.
We are gambling that the risk of an uncontrollable AI is lower than the risk of not having that AI to solve our problems.
That is the gamble. It's the biggest gamble in human history. And every single one of us is at the table, whether we know it or not.
Well, on that cheerful note...
Sorry to bring the mood down at the very end.
No, it's the reality. And it's why we do this, because you can't pay the hand if you refuse to look at the cards you've been dealt.
Exactly.
So for everyone listening, don't just let this wash over you. Don't be a passive observer. Dig in, read the articles, play with the models, try to understand the why behind this incredible new tool, because the world of 2027 is being built right now in February 2026, and you should probably have a say in it.
Couldn't have said it better myself.
That's it for this deep dive. We'll see you in the future.
Take care.